Hey everybody, this is Mike from UX+DevSummit, and in this series I've been talking about the Alexa capabilities and skill sets, and today we are specifically going to take a closer look at the capabilities of Alexa. Now, when we're talking about capabilities, we're really phrasing the skills that are currently capable of the Alexa device. Capabilities is really almost very analogous to skills, but it's actually at a lower level. It's a little lower and more detailed level. So this section is actually to be broken up into multiple parts because there's a lot of ground to cover. So in this one, we're going to start with what is the capabilities and introduce some basic ones. Capabilities, as I mentioned before, are basically skill sets, and you can think of them as a category of interfaces which interface with some functionality that is tied to the AVS or with backend systems. So capabilities essentially provide a number of interfaces which are available for communicating with distinct and disparate systems, more commonly known as smart devices or maybe third-party web services, etc. These interfaces are essential in terms of contracts between the AWS ecosystem and corresponding endpoints. It's also how manufacturers and how third parties know how to implement according to spec, and also how to implement against the interfaces that Amazon provides. So the interface itself is really a contract format that basically describes how to exchange that information from and to. So for example, let's say I'm communicating something to a different system. There's a certain arrangement in terms of these two systems of communicating. A contract is essentially what it sounds like. It's a definition or an agreement between two systems on a specific format in which they can communicate that information to each other. So the first interface capability that I want to talk about is the message. And Alexa transmit directives that are requests on the behalf of the user. So directives essentially are requests and responses, and they have the same structure. They consist of a header, which contains a set of expected fields that are universal, which is used to identify the message transaction. An endpoint. An endpoint is essentially the objects that are used to identify the target for a directive and the origin of the event. So this is useful in terms of where our ultimate destination is going for this message. And the payload. This is what contains the actual information that is being exchanged. In other words, this is the instruction or the particular component of information which is encapsulated, which will be used to communicate, and that receiving endpoint or that receiving smart device will be able to interpret and do something with. So this is where we put that information. And then the context is basically an object that's available to us, which is generally used for reporting the state of an endpoint. So if you think about all of the IoT devices, like thermostats or cooking or anything like that, these types of things would constantly be sending heartbeat signals. As you can imagine, that information is very important. Very commonly, all of these dashboard type applications which you go and there's a lot of visualizations and graphs and all of that stuff. All of that stuff is really, in some systems, a reporting system. So it's basically reporting the state of, like, say, certain devices that are out there. Are they up? Are they down? What is the last known input or endpoint, when are they last available. They also could contain a lot of trace information or message information, and also a lot of valuable data in terms of what the user is doing with that device, and how they're using it. So a lot of different information that you can store there, and essential for capturing information that you can report on. A huge aspect of all of this integration with the cloud and corresponding endpoints and systems and data sets, as you can imagine, there's a huge amount of security that comes along with that. And part of security is authorization. Authorization is basically allowing someone the ability to do something, versus access, which is essentially having the ability to reach an endpoint. So they tend to be related, but in terms of the way that they are developed upon, they typically are decoupled from one another and developed distinctly. So authorization secures your Alexa skills and essentially provides the request to be allowed to be performed on a specific request or response through special directives. So in other words, if we're going to try to even use certain directives, if we're even going to try to make certain requests or do certain things, we need to be allowed to do that. In other words, whether that's the user who is, allowing us or linking our account, trusting us, very similar to like when you're using a Facebook or a Google, you're using your phone and you're prompted with a message and it says, am I allowed to access all this stuff? Essentially, overall, in an abstract manner, you're really trying to accomplish the same thing, right? You're really trying to say, please let me do something on your behalf. And that's where authorization comes in. So the Alexa.authorization interface describes messages used to authorize asynchronous responses and change report events. So asynchronous just means that we are running in a thread that is outside of our current thread. In other words, we're doing something, but we're not holding or blocking any specific process. We're doing this in a fire and forget manner that we are executing in a background that essentially once we've kicked off, we've spawned a process, we've decided to hit that event and it goes and fires and does its thing, and we are no longer waiting for it. We're no longer waiting for a response or a callback. We're not waiting for any of that. We're just letting it do its thing. This interface uses OAuth 2, which interacts with endpoints using a token. This token contains information that allows the endpoint to be invoked. So tokens and OAuth 2. OAuth 2 is basically a specification, and it's based on, you guessed it, tokens. These tokens contain vital information in terms of access and authoritative rights, grants and scopes, and all of those type of security concerns. So when we are issued this token from a token provider, in this case, we are essentially getting a token that allows us to do whatever is configured for our type of user, for our credentials, for our roles, and for our grants. All of these things come together to basically give you the ability to interact with something or do something on its behalf. The next capability interface is essentially related to authorization in terms of the overall workflow of how we interact with, say, a specific device. So in this case, very important piece, not only of authorization, is the discovery of devices that can be communicated within a specific area or within a certain interface. So Alexa is able to discover devices associated with the user's device or service account. So, for example, if you've ever had a Fitbit and you have a Fitbit scale, essentially you have to link that Fitbit scale to the actual dashboard or even the Fitbit device itself. These devices are essentially being linked through your account. It's pretty much the same exact concept. You have a Spotify account and you have an Alexa account, and you need to create a link between both of those accounts, and that's how that discovery process is concerned and created. So you link that association, or there's a device that's within a proximity, and Alexa is able to discover it through a common interface or a common location or center. So this interface describes messages used to request and identify the device associated with the customer's device account. And the directives is a directive. It's called a discover object. It's a discover interface. So an example of this would be, Alexa, discover my smart home devices. If you were to say that, then she would essentially go to your account, take a look at all of the linked information, and then she would then be able to communicate with those devices through those linked accounts. So the next capability interface that I want to talk about is the brightness controller. Now, I want you to consider and picture in your mind a light bulb, and then picture a switch on a wall which either has an on and off, or even the sliders, so that can slide up. If you press it up, it makes it brighter. If you pull it down, it makes it lower. So this brightness interface is a way for you to control and report on the brightness of an endpoint, such as a light bulb. You can use this controller over an Alexa percentage controller interface. Okay, so directives for this are adjust brightness of an endpoint, which accepts plus or negative values, and set brightness value of an endpoint. So In this specific case, we have a light, and let's say we want to change that light setting. We can use these directives to do so. So we can adjust a brightness of, let's say, that light bulb to a specific positive value. If we were to do it to a positive value, that would actually make that light bulb brighter. Now, if we use a negative value, we would actually bring it lower. We also have the capability to use another directive called set brightness. We pass that a specific value, and that will then set the volume or the lightness of the bulb to a specific value. So here's some examples of using that brightness controller. This is what it might look like. Alexa, dim device 30%. And so that would bring that device relative to its current setting 30% lower than what the value was originally set. Versus if we were to set the brightness level at a specific percentage, Alexa set the device at, say, 75%, that is going to use that absolute value of 75%. Versus in the first example, it's relative to the current setting that it is. So that wraps up this section of the first of many capability series within the Alexa series. And I had to break it up that way because there's a lot to cover. But I think you will hopefully start getting a better idea of what exactly the type of interfaces that you can develop in are out there, and in terms of whether you are an Alexa developer or a manufacturer, and you're looking to see how you can integrate into the ecosystem, these are the capabilities that define contracts through which you can communicate. And assuming that you can implement according to those specifications, in theory, you can integrate with an Alexa device and with the AWS cloud. So thanks for watching. Check it out next time. Thank you.